Hi, everyone. Thanks for logging into the Phoenix LiDAR March webinar. This month, we're going to be talking about UAV LiDAR post-processing tips and tricks, and then Phoenix LiDARMill. Just as an introduction, my name is Vu Nguyen. I'm Director of Marketing here at Phoenix LiDAR. Our goal for these webinars is to bring content to our global clients every month, continuing education for them, and also to make sure that UAV LiDAR becomes as streamlined as possible. We've been in the industry for a long time. The very first UAV LiDAR commercial system was a Phoenix system, so we're really excited about that. But since then, we keep innovating with different UAVs, different systems, and we're trying to get better by researching using the newest tech as it comes out. So these webinars will, our goal is to make it really easy to collect that laser accurate 3D data. As you may remember from January, our first webinar was on UAV LiDAR use cases. The second was on flight planning tips and tricks, and it was a great overview by Sam, our chief pilot, on Phoenix Flight Planner, which is, it takes a lot of the geometry out of flight planning, and it's a tool that we developed and made free for all of our clients. And this month, we'll be talking about post-processing with Eric McNeil, one of our post-processing engineers. And then he'll talk also about Phoenix LiDARMill Cloud. So it's the first cloud-based LiDAR post-processing platform. On this call, we have Eric McNeil, one of our post-processing engineers, Eric Agnello, our Director of Sales, David Song, Regional Sales, and Ira Monkvold, one of our post-processing engineers, and myself. At the bottom of your screen, you'll see a quick overview. At the bottom of your screen, you'll see a chat button. So click on that, ask us some questions. We've got the team here to answer them. Without further ado, I'd like to pass the mic over to Eric and have him take over. Eric, tell us about LiDAR post-processing.
Hey, Vu, thanks. So LiDAR post-processing is essentially everything that happens once the data is downloaded. Can folks hear me all right?
I hear you just fine.
Okay, great. Phoenix has definitely come up with some intuitive, very advanced software programs that not only help acquire the data in the field and check diagnostics to make sure your sensor is healthy and is collecting quality data, but we can also use it during the post-processing QA/QC back at the hotel, even in the field, in the back of your truck. So when I'm out in the field and I want to start post-processing data, I'll download it off the unit, depending on, you know, if it's a Regal, a Velodyne, Minivux, Vux, and I'll make a backup copy onto my field laptop. And the first thing I do, even before I leave the site, I will open up Phoenix's LiDAR Systems Spatial Explorer.
Hey, Eric, by the way, your screen is not visible. Would you share your screen, please?
Yes, you just reminded. Share screen. Here we go. Okay, how about now?
There we go, we see it.
Okay. So one thing we're looking at here is if folks haven't seen this, there's a lot of information being thrown at you right now. In the upper right, you're getting your lat long, your attitude of your system, roll, pitch, yaw, and also you're getting verification that your INS solution is good and that you're flying within spec. It's also giving you some just internal information about the temperature of the computer, and also if you're actually collecting what we call packet LiDARs, so under statistics, so you know for a fact that you're collecting data. So this is great out in the field. What I want to do now is come back to, you know, that evening, or like I said, in the back of the truck, and load load this data that we've just downloaded off our system to make sure, just a visual check. We're not really doing any kind of we're not writing macros. We're not doing any kind of measurements to the data. We just want to make sure it's there and it looks pretty, I guess. So I'm just going to show you an example of what happens when we do this. And to be fair, my mouse just broke about 20 minutes ago, so I'm working off my trackpad. So if it gets a little clunky, I apologize. And the great thing about Spatial Explorer is you have a lot of options over here on the left to weight your, your points, your intensity. And then also you get a really good idea of if the data is bore-sighted, is falling on top of each other, to make everything look good. And that's what you're kind of looking for right now. So for a lot of customers who own Phoenix systems, this is pretty familiar for yourself, but you can see the swath building if you follow my arrow. So we're gonna hit pause right here. Also, I'm gonna scroll out. This acquisition was recently collected last week. So this is a pretty big one where they went up and flew, I believe, 5 or 6 missions in one day and just kept hop swapping the batteries to keep the system powered. And it was really an efficient way of doing it. So this is kind of our first step after acquisition, is to just, make sure the data is there. And from here, we're then going to want to take this trajectory and post-process the trajectory, which are, these flight lines back and forth. So our next step is going to move into another software program that's been around for many, many years called Novotel Inertial Explorer, which Phoenix offers, and is a really good software program to really create a smooth best estimate of your trajectory. So I'm going to minimize this and show you another screen. I just need to be smarter than the computer.
So it looks like the Spatial Fuser's main goal is so you can see the data you've processed. Spatial Explorer, sorry.
Yeah.
So you can see the data you've collected, right? And then the trajectory that you've flown?
Correct.
Okay. And then the next part, you're going into Inertial Explorer to start the post-processing, is that right?
Yeah, I just need to find the screen. Where'd it go? I'm going to stop sharing for 1 second. Okay.
I always have things to add, although I'll reserve that and yield.
Okay. So then our next process in the post-processing LiDAR world, and not necessarily even LiDAR world, just remote sensing world, is we want to then merge our our static reference station data with our what I call kinematic data, which is the IMU and the GNSS up in the aircraft. So what we're going to do here is use what I mentioned earlier, Inertial Explorer. And it looks pretty similar to Spatial Explorer, except we're now going to start doing measurements. You can see down here, I've already, to save some time, I've already added the base station data. You can see this is a pretty typical bore site pattern that we do in Duarte, California, which is in LA. It's become a really successful area for us to bore site all our brand new sensors. And what we'll do is I can hit this process. It goes by relatively quickly. And we'll see what our results will be. So what we've done is we've included our raw.nav, that is the nav file outputted from the Phoenix system. We've then incorporated our real known point, which is our reference station data. And then we are doing a calculation in the reverse motion and forward motion. And what we really are concerned about is the difference in that reverse and forward. The smaller the difference, the better. And we usually like an optimal solution would be roughly 2 to 3 centimeters difference. So what we can do here with this software program is we can plot results. And one thing we're really, there's a lot of information here. The two real main values we're working for are combined separation and attitude separation. There are really two quality control values that allow us to know if we can move on. We have an acceptable solution that can give us, that final 1 to 2 centimeter, 3 centimeter LiDAR relative accuracy and absolute accuracy. So we could hit this. As you can see, we're looking at, on the left side, we're looking at degrees for our attitude separation. And our attitude separation is shows roll and pitch values from the GPS and INS processor. We're usually looking for below 2 to 3 centimeters or degrees, excuse me. So as right now, we have a pretty good solution for our X, Y, and Z. Our next one we're going to look at is combined separation. And this is our GNSS. It shows the separation between forward and reverse, or maximum separation between multiple baselines. So right here, we're looking at less than a centimeter. We're, for the most part, on the millimeter scale, which is, you couldn't ask anything better than that. So that's another step in the process. You then want to output your SBET, which again is the smooth estimate of trajectory. And we're going to take that data, and then we're going to move back to a spatial fuser, which is another software proprietary to Phoenix.
And while Eric loads the next piece, you're all welcome. Don't forget to ask questions. Our team is in the chat box there. It's at the bottom of your screen. Hit chat, and we'll do our best to answer them.
Yeah, that'd be great. I'm not looking at the chat, so if anyone's got any questions.
We are.
Okay. So Spatial Fuser, it's a really great program. Pretty simple for what it does. We're gonna add that SBAT data. And what it's going to show us is a map of our study area. It's going to give us a graph. All of these, since there were multiple LiDAR collections throughout this day, you're going to see down at the bottom where my arrows are, LiDAR collections, which this is another good way of determining that your LiDAR was collected during good conditions, and that's why we're seeing solution good and integer narrow lane. We have our Regal. We know this time we flew a mini Vux, and then if you click on that, expand that a little bit, we did 1, 2, 3, 5, 6, 7. We did seven missions. So maybe this first one was a test flight, and all the rest were real acquisitions. So then really all we're gonna have to make sure is output, set up where we want it to go. It auto detected that this is WGS 84 UTM 15 north, but there's also an option to pick whatever you want. If you have a local coordinate system or something not based on the UTM system, and then we have pretty much every coordinate system out there is available to choose from. This usually takes about, it's pretty efficient and pretty quick. For every second the laser is on, it takes about 40 to 60% of processing time. So let's say you flew for 200 seconds. Your processing time to create your .las is roughly about 100 seconds, which is pretty efficient. So that's the three really main software programs that we use to create our .las that isn't using LiDARMill, which is our newest LAS producing software at Phoenix Systems. We're going to go into that in a second. So just to recap, we start off with Spatial Explorer to acquire the data, then do a quick QA QC while you're still in the field. Our next step would probably be the next day to create your SBET and your trajectory that you're going to want to use to assign X, Y, and Z LAS files, so to the best known ability. And then that's being used in Spatial Fuser. So with LiDARMill, it's pretty much a one-stop shop software, and there's a lot to Inertial Explorer in Spatial Explorer, where with LiDARMill, let me pull it up. Hey, Vu, do we have any questions so far that you want me to keep on moving?
So far, we're good. We have a lot of questions, but the team's answering them on the chat.
Oh, great.
Yeah. And while he's loading this to our audience, the best thing about LiDARMill is that it's really streamlining a lot of the more complex aspects of post-processing.
Exactly. And then, so, there's so many benefits to LiDARMill. It's cloud-based, so you don't need a license. Well, you need a subscription, but you can use it anywhere. You can use it on multiple computers at once. There's no real monetary investment like some of the other software programs that cost quite a bit of money. So I'm going to give you a brief example using this hospital scan that was completed roughly a year and a half ago. So I'm just going to go, I'm not going to run through it because it takes some time to process, but I'm just going to go through the motions and show you the results. So with this, LiDARMill processes, so the first step is to upload all your data, which should be right here. So we're going to want to upload, exactly what we do in Inertial Explorer and Spatial Fuser is we want to upload our nav files, our reference file, which is our static station. If we have camera data, this can colorize the points as well. So once we have all our data uploaded, we're going to do something which is called a create a pipeline. And the first things first, something similar to Inertial Explorer is what we're calling nav lab in LiDARMill. And it's really simple. We've already have all our data uploaded, so we're just going to hit next. We're going to point to where we want our stations to be. And then give it a little more information about, do we want it in WGS 84 or NAD 83 2011? There's a lot of options that you can see depending on where you are in the world. And then we're just going to keep hitting next. It's pretty, in my opinion, this is a very user-friendly, intuitive software. Here's our navigation rover, and the navigation rover is the .nav that's collected. Is my screen not showing?
We see your Windows Explorer screen, just like the folder.
Oh, so you're not seeing my...
We're not seeing LiDARMill.
Yeah, okay. Let me try this. Sorry.
You might have multiple browsers. I'm sorry, multiple screens. There we go. Now we see it.
You got it?
Yep.
Okay, let me take a step back now. Thanks, Ira, for letting me know. So again...
Yeah, thanks, Ira. I was answering a question.
No worries. This is where we would upload all our data. So it's stored on the cloud. Our first step would be to create a new pipeline, which is the nav lab, because we want to create our SBAT. And just all that data we've uploaded previously, our nav data and our HCN, which is our static ground station. Just hit next. Include datum, we'll leave it at WGS 84. With the navigation rover, pretty simple. Really the only thing you gotta do here is change, make sure you're using the right antenna. Phoenix always uses the Novatel 2GG 1.03. And then our reference station, which we can put in a custom value. If people are familiar with Opus, it's an online positioning user system. It triangulates close by core stations near your location to to create more of a succinct position. And this is where you can put those numbers in, as well as what antenna you use on your base station, and as well as antenna height, which is very important. Very important where, except for fixed tripods, this is where I see folks mess up the most. Either forget to measure the HI or transpose the numbers, and when they get to the processing side, your data is pretty much useless if your HI is wrong, and there's no way to step back and prove what's right as long as you've left as long as you've broken down your base station. I'm not going to hit finish. That's going to take a little while. So I'm going to go back. So let's say we created our SBET. And I can show you that up here. So these are the files that we create. With using TerraScan, TerraSolid products, you'd want to pull in your SBET, POF, accuracy file. The also great thing about LiDARMill is that we can also download a report. That gives us a lot of information about our mission. And OKs are always good with me.
We laughed at your joke. It's just we're all on mute.
What was my joke?
OKs are good to us too, Eric.
Okay. Great. I love saying OKs, green. And then it gives you your graphs, your charts, kind of like what we saw in Inertial Explorer, but essentially the same results. We're looking at attitude, around 2 degrees, which is great. Position and velocity. So it gives us a little more information we didn't dive into through Inertial Explorer, but that's the other great thing about LiDARMill is it takes months, if not years, to become really proficient at Inertial Explorer. I think it's a really good software, but one benefit of LiDARMill is it's kind of turnkey, really intuitive software that allows someone who might be new to the LiDAR world, their photogrammetry world, to kind of hit the ground running, and this software is great for that. So let's get out of here. Kind of along the same lines.
Hey, Eric, briefly, we have a question from Lydia regarding the trajectories that were run through IE and LiDARMill, and it said there appears to be an attitude difference. It said we were at 0.02 degrees, not 0.06. Why the difference in results?
These are 2 different missions.
That's what I thought. Okay, just wanted to be clear. Thanks.
Yeah. So instead of having to go to the report, we can look at real-time results. And one thing I really like about this is that you can, instead of really having to, you can get a pretty good guess by looking at this, but if you hover over your results, it really gives you in-depth numbers. And this might come in handy down the road, where if you have one flight line that's not really calibrating or coming in, you can come back here and say, oh, this is the spike that I'm seeing in my data. So this might help out troubleshooting down the road. And then you have a scroll bar. You can you can zoom in as much as you want. Yeah, I think LiDARMill is constantly being updated and improved, and the benefits it has, especially for students, small business owners, someone with only one system. I think LiDARMill is kind of the future right now. Vu, is there anything else you think I should be touching upon?
Yeah, could you go over also the point cloud?
Yeah.
Because that's a really nice looking point cloud.
Hey, Eric, real quick too. I have a question here from my buddy Brad. So in IE, I know you have to select a GNSS antenna type. How is that resolved in LiDARMill?
So I kind of skipped over it really quickly. There is an option. Let me pull it back up. It'd be right here. So if you scroll down, is this what you're asking?
Yeah. Yep. I believe that is it. Thank you, sir.
Yep. And then one thing I did skip is we ran the pipeline for NavLab, but we never ran the pipeline for Spatial Fuser, which is actually what's going to create our last file.
Counting the antenna, that's actually two things that you skipped, but I'm not counting.
Well, technically that is counting.
True. So our inputs are our trajectory and our LiDAR data, which is our LDR file, our camera data, and our GCP data, which are ground control points, which we don't have in this data set, which is fine. Our output wants to be a last file. We'll hit next. It's going to ask us for a trajectory that we just created using NavLab and our raw LDR file. And then with our sensors, we're going to want to use laser head as our spatial point source ID. And I could hit finish, but that's going to take a little while, so I'm just going to hit back.
Hey, Eric, Andrew Healy's asking, is there a way to cut or crop the trajectory file in LiDARMill?
You know what? I feel like there is. So do you see the image I'm looking at right now? It automatically cuts it. It might not be the cuts you want, but you can see that it's cutting the turns, and only it's defining what it thinks a straight line is, and outputting. And I think it gives the option to output just that green line, but I could be mistaken. In Spatial Fuser, you have that option.
Okay.
That'd be a question for one of the programmers.
And to our audience, if you have questions that we don't answer, feel free just to ask them in the chat box anyway, and we'll respond. More specifically, if you look at the bottom of your screen, there's a Q&A button. If you type your question in there, we'll get your email as well, and we'll be able to respond via email after the show. The chat box is general, but the Q&A tags it with your email so we can respond.
Yeah, and then it outputs your Spatial Fuser outputs your LAS, which you can just easily download, just like your SBET or your .pof for Regal systems. And then one last pretty cool thing with LiDARMill is we can see immediately our point cloud, and I've already have it open. So so this was a hospital in the local area. So this can give you more of a sense of your project. And this is automatically, once you run Spatial Fuser, this is the last thing that's created. So yeah, so it looks like we've hit the 40-minute mark. Do we have any questions from the Phoenix team or from anyone else?
Yeah, Eric, we had a quick one from Tyler. He says, it looks like LiDARMill did not process the turn trajectories. Is this true? Does the software decide if it processes turn results, or can you choose for it to process or not process turns?
That's a good question. That question goes back into what I wasn't positive on. They've done a lot of changes over the last couple of weeks, and I've been out on other things. So you see this red versus green.
Right, yeah.
As far as I know, it outputs all of your data. And then you'd have to use the TerraSolid products to do the cutting, or Spatial Fuser. But this is definitely a good question, and a question we can follow up with Tyler.
For sure. And yeah, and generally LiDARMill, it's not going to be able to replace the most challenging projects in terms of post-processing. Our goal here is to really simplify for hopefully the majority of projects out there. And as Eric is telling people in the chat, there are a lot of great new features we're coming up with, like classification. So those pipelines are coming soon. So right now we're still in beta with these first two pipelines, so we're going to keep adding them as we go.
Yeah, absolutely.
Cool. Well, please continue to ask questions. For our audience, LiDARMill is right now free in beta as we test it. If you do encounter a bug, we ask that you report it so that we can continue to build the most robust system. There's really not much, there's nothing out there like it right now, so we're kind of in uncharted territory. So if you'd like to give it a try, go to phoenixlidar.com. At the top, you'll see software, and then you'll see LiDARMill there. Or you could just go to lidarmill.com. We bought that domain too. So as people send in their questions, I'll ask the team to interrupt if there's anything that the whole group should know. Otherwise, they'll use the chat feature. But I did want to say thank you to Eric for presenting, and Eric Agnello for being on the chat, along with Ira and David. And thank you all for logging in and joining us. We're going to be at CUAV in Europe in just a few weeks, and AUVSI in Denver at the end of April, first week of May. So as ever, please continue to send us feedback about these. Our goal is to make this as useful as possible, these monthly webinars. The email is marketing@phoenixlidar.com, or you can find us on social media at Phoenix LiDAR. We're on Twitter and Instagram and YouTube. And so please do help us spread the word about Phoenix LiDAR and these webinars. Let us know how we can make this as useful as possible to you.
What's up next? What's next month?
The next month, we're still waiting on feedback for our topics from our audience, but typically it's going to be the last week of the month that we do the webinar. So please do let us know what you would like to see next. We have gotten a lot of great feedback, so thank you very much. And so we'll announce that in our email in a few weeks. So if there aren't any other questions, we'll go ahead and sign off for March. Again, email marketing@phoenixlidar.com if you have any questions. And thanks again to all of our panelists for answering so many questions. We're going to hang out here just for a bit more, just in silence while we answer some more chat questions. But thanks again for joining us. Have a great end of your month.
Thanks, Sue.